Alright, so I'm trying this video again. It's my second attempt, so let's see what happens. I'm going to do standard deviation. This is actually a wonderful topic, and the way it works is there's a normal distribution of data, and so what that really means is you have some data, and some things will happen um, around the mean, and some things will happen further away. And so if you take a look at heights of students, a lot of kids who are, let's say, in the 5th grade will be, let's say, I don't even know, 5'2". But you'll get a couple kids who are really, really short, and you'll get a couple kids who are really, really tall. But most kids will be somewhere around 5'2". And that's just an example. And whenever things are normally distributed, they usually fall in these kind of percentile ranges. Once you have your mean, this is one standard deviation below, and about 34 percent of your kids will be below the mean, or your sample, and 34% will be above. In all actuality, it's actually 34.1% to be a little bit more exact, but we're, for all intents and purposes, we're going to be using this. Below that, it's going to be 13.5%, and this is also 13.5%. And if you can't read my handwriting, I'll write the numbers over here. So the first one, yeah, that's so much more helpful. And then this is 13.5%. Then after that becomes 2.4% and 2.4%, and the very end and is going to be 0.1% and 0.1%. And oh goodness me, that looks atrocious. That should be a 2.4, and that's let's try to make that look like a 4. And so then I said 0.1%, and what this really means is from negative infinity to here, you'll get 0.1% of all your data. If you go from negative infinity to 2 standard deviations, you'll have not 2.4, but 2.5 because it's cumulative, you're adding. If I add again, I get 2.5 plus 13.5, which gives me 16%. And this should make sense. If I go all the way to my mean from negative infinity, I get 50% of all my data. If I continue on to 1 standard deviation above the mean, I then have 50 plus 34%, 84% of all my data. If I add on the next 13.5%, that gives me 97.5% of all my data. And then, ooh, goodness me, I'm running low on space. If I add all the way up from negative infinity to 3 standard deviations, that's going to give me 99.9%. And I'm hesitant to go on any further because really this goes all the way to positive infinity. And when they were talking about a Higgs boson particle, they said, oh, we can't be certain, but we're certain out to 5 standard deviations. So you can see all the way up to 3 standard deviations is 99.9. So I don't even know what 5 standard deviations would look like. All I know is it would be outrageously accurate. So there's one other thing I want you to see. If I look between just -1 standard deviation below the mean and 1 standard deviation above the mean, that's 68%. If I if I look up, hello, my dear, how are you? Hello, Phoebe. Hey. Oh, so now if I add that, I'm going to get 95% of all the data around the mean. If I continue on, let's see, that's going to be 4.4, so that'll be 99%. Is that right? Nope. It's going to be 99.8% of all the data will be between -3 standard deviations and 3 standard deviations. So what does all this mean? Well, let's say I had 70 students who take a test, and I calculate their mean, and I figure out that their mean is an 82%. All right, so that's my X bar, my mean, and I find out that their standard deviation is 4 points. And I say, well, how many students? Well, what percentage of students scored between an 86 and a 90? Well, in order to figure this out, oh, you want to come up? In order to figure this out, you have to figure out, well, 82 plus 4 is an 86, and that's where this is, and a 90 is here. So the percentage of students that scored between an 86 and a 90 is 13.5%, approximately, assuming that this is a normal distribution of your scores. If you want to find out how many students that is, you have to take 13.5% of 70. And if I do that, I get, let's see, 13.5 times 70, and that gives me 945. Well, I know that's not right. Let's see. Oh, you know why? Because I didn't move my decimal. It should have been 0.945, which would give me approximately 10 students. So approximately 10 students scored between there. Oh, no. All right, well, I have to end this video because Phoebe's going to probably end up ending it for me. Last thing I want to say is, if you want to calculate how many students scored below a 90, that's when this other piece of information comes into hand. So below a 90, we know it's 2 standard deviations, but we know that 97.5% of all the students scored below 2 standard deviations. So I said there were 70 students. We find 97.5% of that, and we'll get our answer. All right, I hope you enjoyed. That's it.